Alright, so we're gonna look at this classic problem of given a parameter L, what shape would achieve maximum area? Alright, so of course the common shape would be triangle, rectangle, circles, and the regular polygon. Alright, so let's look into that. So first of all, for the triangle, you know that there is a formula, Heron's formula, that calculates the area of a triangle, where here S is the semi-parameter. In other words, if this is given constant, here S would be L over 2, is of course A plus B are the three sizes, yeah, and over 2. Okay, so we're given L is constant, which means S is constant. S constant, right? So we try to maximize the area here. How do we do that? So one of the useful tool is what is called AMGM inequality, right? Which says if I have n positive numbers, what I'm gonna get is that the arithmetic mean is greater or equal to the geometric mean. All right, so we can use that to find out the maximum area here for the triangle. Let's do that. So we notice that S is constant, right? So this is constant, so only variable term is here, right? The three terms here. What if you apply AMGM, what this gives you is that we have three numbers, so that means you have the third square root of S minus A, S minus B, S minus C is going to be less or equal to the original mean, which is 3, and then S minus A plus S minus B plus S minus C. Here, notice that A plus B plus C is equal L. L is 2S. 3S minus, 2S, that is S, right? So this is S, right? But then S is half of L, right? So remember, S is a semi-parameter, and L is given, so I have L over 6, right? However, we're interested in the area, right? This is, you're going to raise to the third power, right? And here you would have this raised to the third power, right? So what you get is so one, and then what you have is S minus A, S minus B, S minus C is less or equal to L to the cube, and then 6 to the cube. All right, so the area is square root, so the area here is square root of S times the square root of this one, right? So square root of this one times this is area, times square root of S, what is S? S is L divided by 2, right? So what you get is that this equals square root of L to the first power, and here you have 2 times 6 to the third power, which is 2 to the third power, times 3 to the third power, right? So which means what you have is L squared, right, over this one. You have 2 to the first power, you have 4, right? And then you have 3 to the third power, you can get 3 out of it, and then square root of 3. So the maximum, this is the maximum. When the equality holds, AMGM says when the equality holds when x1 equal x2 equal xn. So in our case, it means this is achieved when S minus A equal S minus B equal S minus C. In other words, is a regular triangle. Alright, let's recap the steps. So first of all, this is from the AMGM, yeah, inequality. And then this is the area formula here. And then the final here is, this is the maximum, right? So, right, how about rectangle? In the rectangle, if the side length is AB, yeah, if this is A, this is B, we're given that the parameter is constant, so we need to have A plus B, yeah, must be L over 2, right? And the area is AB. This is AMGM, yeah, for two numbers, you're gonna get this. So the area here, sorry, we're missing something here. This should be square, okay? So, and then this is L square over 16. So the previous result is L square over 12 square root of 3. For the triangle, here's L square over 16. Of course, this one is bigger than 16, so that is smaller. So in other words, given the same parameter, you want to choose square rather than triangle, right? Square is bigger. Now, how about circles? Now, recall that in a circle, yeah, so if I have R, the L would be 2 pi R, the parameter. The area would be pi R squared. So here, because L is given, so R is fixed. In other words, R would be L over 2 pi. So if you plug in, what you get is pi L squared 4 pi squared, which is equal L squared and 4 pi. Now, think about the previous square, right? Square is bigger than the triangle, but square is L squared over 16. Yeah, over 16. And here's L squared over 4 pi. You know, pi is about 3.14, right? 3.14. And of course, which one is bigger? The circle is bigger. So among triangle and rectangle and circle, you want to choose circle to achieve maximum area. Now, how about, so this is the result for the circle, right? Yeah. So how about n-side polygon, right? So here I have 6-side polygon here. Now notice that here I mark it theta, right? This angle here, theta, would equal 2 pi over n, right? Inside it here, usually n is greater or equal to 3, right? So now the area of polygon, in this case, yeah, the area would equal n times the area of the triangle OAB. So what is the area of triangle if the side length is A? This is side length. Yeah. So side length is fixed. Why? Because side length is L divided by N. We are given L as a constant, right? So here, this triangle here, what you can do is, let's see, if this would be edge, right? Edge here, right? So notice that the triangle is 1/2 of base times edge. So what is edge? Now edge is related to A with this, relation, right? So half of A, which is this segment here, let's mark it in a different color. Here, this one over here, right? This is half of A, yeah? A over 2, right? And then over edge, would equal tangent of theta over 2, right? So in other words, h, okay, yeah, it's here. So h equal a over 2, yeah, what is a over 2, yeah, divided by tangent, what is theta over 2? Theta over 2 equal pi over n, pi over n, alright? So plug in here, in this equation, what we get is, it's going to equal, right? So n, what is a? Yeah, and h, you have a squared, right? Over 4 tangent pi over n. And here, if you plug in a is L over n, right? So a squared is L squared over n squared. You plug in L squared for n squared tangent pi over n. So that's equal L squared for, yeah, n tangent pi over n. Right, so let's do that. L squared for n tangent pi over n, right? So you can plug in n equal 4. Let's try that. N equal 4, that would be square, right? So here would be L squared over 16 times tangent pi over 4. That equal to 1, right? This is equal to 1. So this is L squared over 16. This matches with previous results of a square, right? Yeah, the square is L squared over 16. All right. So look, we got this for different n. So let's look at this sequence here, this particular quantity, right? Because it's in the denominator here, right? So let's look at this. Now, in order to find out like the trend of this sequence, I have a typo here. All right. So for this function, let's take a derivative of fx. So f derivative is going to be, let's rewrite fx, yeah, equal x over tangent x. Tangent is actually sine over cosine, right? So it's going to be x, and this is sine x, this is cosine x, right? All right, so if you take derivative, that would be sine square x, yeah? Remember, we have this rule, right? Like u v derivative equal v square u prime v minus u v prime. Okay, let's do that. So here, the derivative of x cosine x using product rule is equal x sine x plus cosine x, right? And then, so you have, let's write it, is cosine x minus x sine x. You're gonna times v, right, which is sine x, minus u, which is x cosine x, times v prime, which is cosine x. All right, so if you simplify this, you're gonna get, all right, so this is actually equal to 1. So what I get is 2 sine square x sine 2x minus 2x, right? So we notice that we care about this interval here. So this is actually f prime x is less than 0. So this function fx is decreasing. Yeah? Okay. So, but if we choose x equal pi over n, then as n goes bigger, x smaller, so fx is bigger. In other words, this here, if we look at pi over n, yeah, tangent pi over n, this is increasing as n gets bigger. Right? So that's something we need to know. So in other words, for the fixed L, you want n to be bigger in order to achieve bigger area. Of course, you're going to naturally ask, what if n goes to infinity? Yeah, let's look at that. So recall that sine x over x as x goes to 0, that's equal to 1. All right. So let's look at the quantity we're interested in is this one, right? So L squared over 4 pi, 4n tangent n over pi. N tangent n over pi as n goes to infinity, right? Positive infinity. So here that'll be L squared. Let's look at 2. Let's put n over pi here and get a pi here, and then tangent, let's rewrite it as sine and cosine. So we have sine here, n over pi, you have cosine n over pi, actually pi over n, pi over n, as n goes to infinity. Right? So here this achieved to 0, so that's equal to 1 on the top, equal to 1 times 1. Over here, what you can do is this one, yeah, is equivalent to pi over n. This whole quantity here, yeah, this whole quantity here goes to 1 as n goes to infinity. So that is 1 times 4 pi. So the limit is L squared over 4 pi. This is exactly what we get when we have a circle. Alright? So in summary, if we want to achieve max area, you want the shape to be a circle. Yeah? A circle. And where the area maximum would equal L squared over 4 pi. Of course, L is a parameter, right? So that's the main result, and hope you enjoy the video, and please review the steps to understand how we reach this conclusion. with combination of some AMGM property and also some basic calculus. Alright, please subscribe to the channel for related topics on this. Thank you.